Hello, and it's Mr. N. I'm here to try to help you with some more complicated trig equations. And as you see in front of you, there are three problems in front. First, we're going to factor each one of these and see how it goes. And then we'll set them all equal to 0 later and solve them. So let's look at number 1. And even though there's some messy numbers in there, how would we factor number 1? Well, it turns out it would be the Gcf method of factoring, because all you can really do is factor out an x. And if you do, you would get 2x minus root 3, because that's negative root 3 times x. It's not all under 1. And that would be it for factoring the first one. For the second one, that's our traditional trinomial. However, notice the a is not 1, it is 2. So we have to do our mega x bottoms up, where it's the b number goes on the bottom, so positive 1, and a times c goes on the top, and that would be negative 2. And what numbers multiply to negative 2 and add to negative 1 would be 2 and minus 1. But that's not it. Because of this, we have to divide everything by that number and then reduce. This fraction doesn't reduce, so it's set. This fraction reduces to 1 over 1. So our final answer is 1x plus 1 from here times 2x minus 1 from here, and that is now factored. And then our last one here, you might recognize that. It's been a while. It's a difference of 2 squares. All right, well, it's x squared minus 1, and that's 1 squared. So that just factors as x minus 1. You copy it without the exponents, and then x plus 1. And everything is factored. That is done. Okay, now before we get to the solving, for solving, we're going to set each of these equal to 0. So that's a slightly different problem. All right, but before we get to that, let's just look at the factoring again and now look at these problems. Now, they have trig functions in them, but if you really compare them, the trig function you see, 2 cosine squared x minus 3 root 3 cosine x, is similar to just 2x squared minus root 3x. And same with this. If I just turn these x's into sines, they really are the same thing. And instead of x squared, I have tangent squared. They're all very, very similar. Instead of just having a plain x, I put a trig function of some kind in for x. And if x is squared, then the trig function is squared. Just like here, x squared, tangent squared, 2x squared, 2 sine squared x. All right, so it actually is the same thing. These trig functions can also all be factored in the same way. This can have a GCF of just the cosine x. So you could factor a cosine x out of everything, and if you do, you'd be left with 2 cosine x minus root 3. All right, because there's 2 cosine x's there, and there's 1 here. So the 1 factors out, and if there's 2, 1 gets left behind. And that is factored using GCF. Here, it's a trinomial because it's x sine squared, sine, and a plain number. And you can do the exact same thing, right? Except before, we already did it. It's here. Instead of just x plus 1, though, it's going to be sine x plus 1 times, and instead of 2x minus 1, guess what? It's going to be 2 sine x minus 1. So that's how that factors. Just pretend instead of a sine squared x, just pretend it's x squared. And instead of sine x, just pretend it's a regular x. Pretend it looks just like what we saw here. And then for tangent squared minus 1, again, same thing. That's going to factor into tan x minus 1 and tan x plus 1. So everything factors in the same way that you know. There's GCF factoring. We can factor out a single trig function. There's trinomial factoring, and there's difference of 2 squares factoring. And they can work with regular variables like x, and they can also work with trig functions. Now, let's go back to the algebra, and let's go to the solve section. Now to solve, once you factor something, once you split into 2 groups, if those groups equal 0, which I did do for all of them, they all equal 0, you can use the zero product property, which says if 2 groups equal 0, you set each group equal to 0. And then that's a root 3. Then you can solve each group. This one's already solved, and this one would be 2x equals root 3. Divide both sides by 2, and you get root 3 over 2. And those would be your two answers for number 1 if you solve that. And then same here, x plus 1 equals 0, 2x minus 1 equals 0. You get x equals -1, and skipping ahead, 1/2. And then here, you get x equals from here plus 1, and from here minus 1. Or you could also say that as x equals plus or minus 1. You could write that either way. Okay, so that's how we'd solve those. We use the zero product property after we factor them if they equal 0. Now, I can do the same thing to each of these trig things. I can set them equal to 0. Now, what do you do if they're not equal to 0? Well, you move everything to one side until it does equal 0. But if everything equals 0, then you can still use ZPP on these trig functions. I'm going to take this away for now. All right, so ZPP here, you'd have cosine of x equals 0, and 2 cosine of x minus root 3 equals 0. You have two separate equations. Now, actually, when you think about this one, use your unit circle. When does cosine of what number equals 0? And we're going to solve all these from the interval of 0 and 2 pi. All right, so just one time around the unit circle. All right, and if you do that, x would have to be pi over 2, because when you have the cosine of pi over 2, the cosine of pi over 2 equals 0. It also happens at 3 pi over 2. So those would be your two answers for this part. Now this part, I gotta keep working out. Let's get the cosine x alone. So we'll do 2 cosine x equals root 3, because I'll just add it to both sides. I can divide both sides by 2, and I get cosine of x equals root 3 over 2. And that is something we can solve. What values for cosine? Cosine of what equals root 3 over 2? Well, if you look at your unit circle, I believe it's going to be pi over 6. And I think it's also going to be 11 pi over 6. And so altogether, this equation has 4 different answers. Okay, hopefully I got all that correct, but those are your 4 answers. And so now we were able to solve this trig function. We solved it from this interval by factoring out the GCF, right? Factoring out GCF, setting equal to 0, and then taking the two groups, splitting them equal to 0, just like we used to do right here. Right, same idea, factor, set each group equal to 0. Okay, but now we're doing it with trig functions. So exact same idea, right? So here, if I ask you to solve that trig equation, you notice it factors like this, right? By using the same trinomial method as before. I just pretend these are x's, or whatever you want to call them. Just pretend it's just 2x squared plus x minus 1, just like we did here. All right, so just factor it this way, and instead of x's, write sine. So x plus 1 becomes sine x plus 1. 2x minus 1 becomes 2 sine x minus 1. And then same thing here, use ZPP. So we have sine x plus 1 equals 0, and 2 sine x minus 1 equals 0. Solve each one of these. Sine x equals -1. And where's the only place where the sine equals -1? And that, I believe, is going to be at 3 pi over 2. Hopefully I'm correct on that. And then here, 2 sine x equals 1. Add 1 to both sides. Divide both sides by 2. Sine x equals 1/2. So now we have to ask ourselves, what's the values of sine? Get us 1/2 for x. And I believe it's going to be at pi over 6. I think it's also going to be at 5 pi over 6. So all 3 of these answers together. Notice this one had 3 answers. That one had 4 answers. It's very common to get 4 answers. 3, sometimes you'll get 2 answers, and there's rare cases you might only get 1 answer. So it just really depends on the problem. Okay, hopefully I got all these correct. And then the last one for number 3, same thing. Set each group. We factored it using difference of 2 squares. Got 2 groups, so we have tan x minus 1 equals 0, and tan x plus 1 equals 0. So we're going to end up with tan x equals positive 1, and tan x equals negative 1. And we're going to have to ask ourselves these work. For here, the tangent equals 1 at, I believe, pi over 4 and 5 pi over 4. And over here, the tangent should hopefully equal negative 1 at 3 pi over 4 and I think 7 pi over 4. So again, 4 answers. Usually if you split into 2 groups, each group will have 2 answers, typically, but not all the time. Over here, the sign has only 1 answer. There's only 1 spot where the sign equals negative 1. I hope this helps you. This is your first step in how to solve trig equations and that you can factor trigs. When you get stuck, just kind of forget about the trig stuff for a moment and just replace them with a regular x. Right? Just take everything, if it looks too complicated, just change everything back to regular x's and just factor accordingly. Right? GCF, trinomial difference of 2 squares. There's technically still grouping and sum and difference of cubes, but those are very, very rare in trig functions. While they can happen, I don't believe they're going to happen to you here, although it is a possibility, but we're going to keep most everything either GCF, trinomials, or differences of 2 squares. So hopefully this helps you on your first step to solve trig equations.